Hold on, I'm going live on YouTube. Yeah, we're going straight into it, straight into the thick of it. um, how's everybody doing? He has motivation. Yeah, I do actually. I kind of made a random generation system, or I got some of it down. And I even made it so we can enlarge in the space as well, which is fun. Although it's not like 100% perfect. But yeah, I can allow backtracking, do some crazy stuff. So yeah, yesterday I did this whole thing. I set up this whole thing. I set up kind of like a path generator, so we can guarantee at least one way to get to an area. Now it's just about figuring out the rest of it. Well, I got to figure out the rest of the thing, which is obviously going to be a challenge. Yeah. This is the very basic version, though. Is that PCG or C++? Glad you asked. It's Blueprint. It's actually quite basic in nature. Someone showed me a algorithm called drunkard walk algorithm. And this is kind of, I feel like, inspired by that. Basically, from what I remember reading, the drunkard algorithm, or the drunkard walk algorithm, basically kind of randomizes going left, right, forward towards a direction or whatever. And then I was like, we can kind of do something similar to this. So this basically has rules and checks, can we go up or down, or whatnot. Actually, wait, no. This one checks if we can backtrack. So going backwards. Then this one checks if we can go up or down, and then a random chance of going up or down, or going to the right. Because everything is based off of just going to the right anyways. So it'll kind of randomize like a pathway. Now this is like a very basic version. We have to actually start getting the pieces in, and then we got to work on the rest of the like wave function collapse algorithm or whatever we end up doing. So that we'll have to figure out. What component are these points? These are just debug arrows. The lines. And then they just disappear. Just to kind of give me an idea of like, does this know where we're going? I set up all of these into levels. And then, yeah, now we have to, I also set up a struct for all of this so we could start keeping track of all of this data and information. What is it, by the way? What is it for? Well, two uses. We'll have train cars that are kind of randomly generated. We messed around with that last stream, which I think was yesterday. And it felt pretty good. Just having kind of random rooms and stuff like that felt pretty interesting. So I was like, fuck it. We can have some cars that are just randomly generated things. what I think I ended up discovering though is that it's a lot more fun if a car has more randomized elements in it beyond just item spawn points. So I think that's what I kind of pinpointed, which was one of my predictions of why I felt like the game was kind of not very fun. Once you've explored a car, you kind of know what's in the car, where to go and whatnot. So this will be used for this, but we can also reuse this code and stuff once we get it working in the stranded tunnels. We could do that too in the stranded tunnels. And then maybe in other areas too if we wanted to. Yeah. Also, kind of a cool thing to learn for maybe a future game. Or maybe even Suit for Hire. You could do a wave function collapse for the roguelite levels. That could be kind of sick. I don't know if they would look very good, but we can give it a try. Yeah. And fist. Stop rubbing your eyes. My eyes are itchy, man. Leave me alone, dude. Come on. What are you, my mom? So yeah, it's a bit of a stupid system. It's a bit of a dumb system because I don't know how else to do a path solving system where it will 100% guarantee it to go to a point. So what it ends up doing, if I increase the size of this to like 10 by 10, and let's say I set my goal point to like to there. Once it reaches the end, it's either going to go up or down to reach the point. I don't know if that's smart, but yeah. And then here we could do backtracking, so we can have pathways that go like in and then back out. But we're not going to need this 100% of the time for like random generation stuff. This is more so for like, okay, hey, we need a pathway or something. So that's kind of the idea there. But this can't, I did not set up this in a way where this index point can be, the goal point can't be like in the middle here. It has to be at the very end. That's how I coded it. So kind of shit. Not the best like algorithm ever, but whatever. Steam Deck to 45 to 55. That's not too bad. Yeah, today I felt inspired to work on how we're gonna end up doing this whole like thingy here. I was watching this video. I also noticed the mesh rotation. It might be a good idea to actually use mesh rotation as a thing here. Might be a good variable to put mesh rotation in there too, actually. But then, dude, it kind of sucks. You have to keep making a bunch of inputs for this. I think this is a JSON file. Can you read from a JSON file in UE? I don't know. I don't think so, guys. Whenever I see a JSON file, I'm like, oh, dude, this is like real game dev. I don't know what it is about seeing a JSON file. I think it's like, I've seen it all my life. I'm pretty sure Minecraft uses a bunch of JSON files, right? Yeah. But yeah, this kind of helped a little bit. I was watching a bunch of other videos about this algorithm as well. It would be nice if I can have like a piece, like for example, the corner piece. If I can have it so it just generates its own versions of where it could go. But I guess it is easier just by having it in as inputs. I don't know how because there's actually a wave function collapse plugin, but it's experimental. I don't know how it determines stuff like that, like corners, and I don't know how it saves that data. I don't know if it says it saves it to like just a data asset with a big array of stuff, or yeah, I don't know. But I guess it would be easiest doing what he's doing here, which is saving the mesh rotations of them. Yeah. Yep. Would it not have been easier to build each room type with X number of doors and just enable or disable the doors? Build each room type with X number of doors and just enable or disable the doors, depending on the calculated path. What we're gonna do is, it's very basic, right? These scenarios, they have like types of prefixes or like suffixes, like they got S, F, S, that like defines very like stuff. I just have to define where there is a doorway or not. That's basically it. That's basically it. So that's it. But we still have to feed that data in. We still have to feed that data in. And then I turn them all into levels, because that means from here, what we can do is start placing other actors in here, and then we can maybe start creating variants and whatnot. So then that way it's not just a mesh, it's also got other things inside of them as well, which I think is good. Yeah, and then we just add them in as level instances. That's it. So they look like this. Level instances, and then we can edit them and whatnot, so. Yeah. So we'll see how we end up getting on with this. I guess the first piece of the puzzle is, where do we keep the data of all these things? We could do a data table. Ideally, I would not want to use a data table, but I guess a data table is, we could use a data table. Data table might not be a good idea though, now that I think about it. Like just a simple array might be the best way to go about it. Array of rooms in the level BP. Well, we have the BP random generation manager, but I don't know how the wave function collapse works. Does it just create, for every little tile, does it start having its own array of options? This, I think, is just generating the JSON file. Make 1,000 versions of each to have it pick a random one each time. See, this reads from the data. And then it initializes it. So what is this doing? For x in range, size.x, x.append all prototypes duplicate. Oh, so every tile is an array, and then it breaks through the array depending on which things are invalid. I think that's how the wave function collapse works. Every tile is an array of the options array by default at the very beginning. And then once you place one tile, it then starts filtering through all the other ones to see if there's any parts that are not allowed. I don't need a specific path. Yeah, once you start adding a path, that's, I think, when things get a lot harder. I saw a bunch of posts about people showing the path stuff, but what a lot of people say is they just use a different algorithm for creating the path, and then they just create the other pieces. So like what I'm thinking would happen here is like this would pick from any, it would basically filter these to specifically pick ones that have at least the door, at least two doors, one that is the entrance and one that's the exit, right? So this would know, okay, I have to at least pick one of two things, a corner piece or a T, right? So it'll filter out anything that has a wall here or here. And then this piece, it's door here, and then it can't do anything here because it's boundary. So this would have to be walls, right? So that's kind of how I'm picturing it. This one could in theory be a T, but it has to be a corner at the very least and a wall. So that's how I'm kind of picturing how this would work. Yeah, what if you just made all the levels have doors on each wall, but when it's finished, you can just close off the doors that aren't on the main path? Yeah, you could do that, but the nice thing with this is that it will try to generate other paths as well, technically. So it creates a little bit more randomization rather than forcing 100% the pathway. Another thing that's going to be really interesting to figure out, if I even can, is multi-tile pieces. Basically, by that I mean, let's say we generated this room, but we wanted this 2x1 piece. I literally don't know how this would work. I don't know how we would make that work. We would have to have that as some form of data there. We'll figure that out in the future. Let's just stick with our 1x1 pieces. And then when we have 2x1 pieces or corner pieces or whatnot, the system would have to skip over the tile that it takes up. So the biggest thing here is if each tile is reading from its own data and then something suddenly takes up a slot, we just have to somehow notify it, hey, we've taken up this slot. So don't generate anything in this slot anymore, kind of thing. That's going to be interesting to figure out. Why not have the whole area as one large volume that the walls and doors are generated as needed? We could have done that way. I just kind of liked having it like this because then we can do a lot of interesting stuff with these pieces. Like, for example, the tight corridors, for example. So, like, we could have done it that way where the floors are just preset and then you do the walls. We do the walls and the doors as its own thing. But I felt like it's just easier for me to do it with like this. First time doing anything like this, so who knows? It's probably going to be fucked. I had this like diagram of like how I would picture how this would go through. And then I also had numbers because I needed to figure out how I'd end up reading this data as just singular integer values and not like x and y's. Which is pretty simple. It's literally just you take a value and then plus the x span or whatever. And then, oh, hey, now you have the other row or whatever. Yeah. It's not the smartest thing ever. Like I said, you know, even when you increase the size of this stuff, it's technically not like the most correct thing in the world, but it's a cool thing. I like doing stuff like this. Stimulates the brain. Stimulates the brain. But yeah, we could have done walls. We could have done walls as our version. Like walls could have been the thing for sure. But yeah. Now you wait until you're not streaming to do actual work? What do you mean? So is this so propagate stack.append coordinates? Iterate over each adjacent cell to this one. So this is where I think Blueprint will get kind of laggy to figure this stuff out. But we're just going to do the prototype in Blueprint. And then I think we would want to probably convert some of this stuff into C++ because there's going to be a lot of looping. A lot of looping. A lot of looping. Sounds like a Googler. I do be doing the Googling a little bit. Luckily, we don't have to do any of these like really conditional stuff like 0s. It's literally just going to be 0 or 1. 0 means wall, 1 equals doorway. And then in the future, we'll probably introduce z. Right now, we don't have any z, so that means like it's just going to be on one flat plane. But in the future, we are going to make it so it's like you can go up, at least one floor up. But yeah. Neighboring tiles. Positive X, tile 1, tile 3, tile 8. That part I don't understand. Neighbor lists. So does this generation system also have to keep track of the tiles that are next to it? This is an array. Do we have to keep track of every neighboring tile? Oh, right. So this is a... Bless you. Thank you. Thank you. Thank you. They're aware of every tile around them. So I guess, is that how it's propagating? Like, is that how it's basically, once this updates, it's going to tell all of its neighbors to then update their potentials, and then those will update the other potentials, and then it'll like kind of ripple from there? I just don't understand tile 1, tile 3, tile 8, positive X. Let's just watch let's watch this video, because this might be just a good I'm gonna rewatch it again. We'll rewatch it together. We'll rewatch it together.
Propagating these new consequences to cells neighboring that cell, and so on, to a single possibility. Once this occurs, we can say that the wave function has collapsed. As you can see, the wave function collapse algorithm is actually pretty straightforward, and because it bears more than a passing resemblance to the process of solving a Sudoku puzzle, it's even more...
Because ideally, I guess the idea is we wouldn't want to go through every single piece in the tile to check if they've been different. So I guess doing the neighboring tiles, you kind of make it to the code instead.
Straightforward to explain and intuit. Now that you have a good idea of how the wave function collapse algorithm works, we need to talk about those adjacency constraints I mentioned.
You only need immediate neighbors? Not 100%, because like if you look at this, right? So this is slowed down really slow.
This algorithm is actually...
But you can see it's actually filtering out multiple pieces around as well, not just the immediate neighbors.
Pretty straightforward. And because it bears more than a
see, it's kind of going through everything.
Passing resemblance to the process of solving a Sudoku puzzle, it's even more...
For your case, I mean? Yeah, I guess it would only need the immediate neighbors.
Forward to explain and intuit. Now that you have a good idea of how the wave function collapse algorithm works, we need to talk about those adjacency constraints I mentioned earlier, as this is the thing that you'll find varies the most between different wave function collapse implementations. Here are the modules I'll be using for my wave function collapse implementation. They're all built to a 1-unit cube grid, ready to be slotted together. Next, we need to find a way to tell the wave function collapse algorithm which modules can slot together and which ones can't, and in which directions. It needs to know that this is valid, but this isn't. There are a few ways to achieve this. The original...
Didn't do any of this. There's a way to like generate all this into a file. I didn't do that. We're going to be doing this manually.
Wave function collapse implementation has a novel approach and includes an additional step before running the solver that analyzes an example of what the output should look like. It can then break the example down into tiles and check which tiles are placed next to one another, and will consider those combinations valid. I've actually already done another wave function collapse implementation.
Although generating this probably wouldn't be too difficult from a data standpoint. We would literally just have to do a line trace. It would just have to do a bunch of collision checks from the center point to determine where doorways are. You know what I mean? So it's not the worst thing ever.
That does exactly this, using a tile map as the input. Before running the solver on a blank tile map, the algorithm looks at the example tile map and takes note of which tiles are present, and any tiles that are adjacent to one another in the example are considered valid neighbors when solving the wave function. You can have a play around with this on itch. The link is in the description. Another way to decide which neighbors are valid and which ones are not is to use a socket system, marking up each tile edge with some kind of identifier and invalidating adjacency for any tiles whose sockets don't match at the cell boundary. Something similar can be seen in this now famous wave function collapse demo by Oscar Stahlberg, also linked in the description. Here, each tile's socket is dictated by the color of a pixel at 3 fixed points along each edge of the tile, and adjacencies are validated based on whether or not the adjacent tile's colors match at these 3 points. For this demo implementation, I'm going to be using a system heavily inspired by this also pretty famous Infinite World Wave Function Collapse demo by Marian42, and here's how it's going to work. In order to validate adjacency between modules, each module is going to need to contain 6 lists of valid neighbors, 1 for each boundary face. Whenever we collapse a cell, we can then remove any modules from neighboring cells which aren't present in our list of valid neighbors, just like in the first wave function collapse example from the beginning of this video.
So this is for generating
lists. We'll need to label each module with sockets, 1 for each face, then check the validity of modules being adjacent to one another by checking their sockets and consulting some simple rules about which sockets may or may not fit together.
Right.
The first thing we'll do is loop over every module in our set and store the positions of each vertex that sits along each edge of the 6 boundaries. We'll store and label these boundary profiles as we go, assembling a dictionary of socket names and their corresponding profiles. There's also some special markup we need to do for symmetrical and asymmetrical sockets. We'll tag symmetrical ones with an S in the socket name, because we know that regardless of orientation, a symmetrical socket will always fit with itself, whereas asymmetrical sockets will only ever be valid when placed next to a mirrored version of themselves. We do this by mirroring the vertex positions of each socket and checking if they're still identical. If they are, then we label the socket as symmetrical, and if they're not, we store the flipped and unflipped versions as 2 different sockets and mark one of them with an F. For the top and bottom boundaries, we have to do something special as well, storing 4 versions of each socket, labeling them with a rotation index 0, 1, 2, or 3. Vertical sockets will then be considered valid neighbors if they have the same socket name and rotation index. As we analyze more modules, we'll find that we've already come across some of these sockets, and instead of storing new entries, we can instead just apply the matching socket name and move on. Eventually, we'll have marked up every single module in our set with sockets.
What the? I'm definitely gonna have to make some sort of system to do this for me. Like, I'm not making meshes as complicated as this, right? So like, I think hand doing it right now, not gonna be a huge problem. You know, it's literally just a 0 or a 1. Is this a doorway or not? Kind of deal.
It's time to start building those lists of valid neighbors using all of this information we have. Before moving on to creating the actual neighbor lists, we'll need to talk about the concept of prototypes, which is borrowed directly from Marian42's implementation. Prototypes are the metadata for our modules, containing information about which mesh to use, what the rotation of that mesh should be, and the 6 lists of valid neighbors. This allows us to get around needing to export 4 different meshes for each module to cover all possible rotations. Instead, we just create 4 prototypes that reference the same mesh, but with a different rotation index for each. We'll be writing our list of prototypes.
Yeah, so I think for the rotations, I'm going to have to make them all as separate pieces.
Same mesh, but with a different rotation index for each.
So the neighbor list, is that what I did here, which is x positive, x negative, y positive, y negative? Should I turn this into its own struct rather than separate values? Might be a good idea. We're also going to probably want a rotation.
We'll be writing our list of prototypes to a JSON file, which we can load in our game engine as a...
See, here he has this, but then he also has the neighbor list, so I don't really know.
So let's start building prototypes. For each of our modules, we'll create 4 prototype entries, 1 for each rotation. At this stage, the prototype will contain only the mesh name, rotation index, and list of sockets, which we'll swizzle around depending on the rotation index. Now we have a list of every possible orientation of every module. Next, we'll need to compare each prototype with every other prototype 6 times, once for each direction. We'll check that the opposing sockets are valid using our adjacency rules, and if they are, add the other prototype as a valid neighbor to the relevant neighbor list for this prototype. This might seem like a lot of repetition, but to create the prototype list for this admittedly small set of modules, it only takes about a second. One final thing to note is that a module might not contain vertices.
You could have each room data driven, so you can look up each possible legal room type based on there being a door and a wall facing. So is the neighbor list basically pointing at every single other mesh that's possible in that area, but doing it just raw here and then saving it rather than you having to compute it in runtime? Oh no. I think so. I don't doubt it, because then it'd be a lot quicker to determine what things are allowed on the other sides, right?
But to create the prototype list for this admittedly small set of modules, it only takes about a second. One final thing to note is that a module might not contain vertices along every boundary face. So when this happens, we store the socket name as being -1. And after creating all of the prototypes, a blank prototype is added to the list with -1 sockets along all faces and no mesh reference. This allows our wave function solver to place blank space in the same way that it places meshes, and so simplifies the whole process a little bit. And that's it, we're done. We've got all the data we need to start implementing our wave function collapse solver. Here's what the prototype data looks like, and here are all the meshes they reference, ready to be loaded into the engine. I won't be going over the code that does all of these steps line by line, simply because it's 400 lines and a bit messy, and so doesn't make for good entertainment. If you understood everything up until this point, and you know how to do a bit of programming in your DCC of choice, this should give you a really good head start. If you'd like to get your hands on my code, you can find it over on my Patreon page, linked in the description. Next up, we'll need to write our wave function collapse solver in Godot. Again, the code for this is quite long, so I'm just going to cover the most essential parts. First off, we need to load our prototype data.
Room type 1, and it would only need 4 values, 1 for each wall, with 0 being a wall and 1 being a door based on predetermined face direction. 0, 1, 1, 0 would be wall, door, door, wall. Yeah. Yeah, exactly. Which I feel like is a lot cheaper and probably easier to calculate, but I wonder if it's going to have, I don't know if...
And this is the function that does it. As you can see, I'm simply opening the JSON as a text file from the root directory of my Godot project, then parsing the text result to return a dictionary. Next, we initialize our wave function, which is as simple as creating a 3-dimensional array, filling each cell with a copy of our prototype data. Then, to get everything started, we create a while loop that breaks if our wave function is fully collapsed. This function simply checks if any of the cells in the wave function still contain more than one entry. If it hasn't fully collapsed yet, we tell the wave function to iterate. The iterate function should sound familiar from the beginning of the video. First, we find the cell with the lowest entropy, which we do by looping over the cells to find the one that contains the lowest number of possible prototypes, with some randomization in case there's a tie. Then we collapse the chosen cell by picking a prototype at random from its list of remaining prototypes and remove the rest. Finally,
Excuse me, wait, what was that?
Which we do by loop fully collapsed. This function simply checks if any of the cells in the wave function still contain more than one entry. If it hasn't fully collapsed yet, we tell the wave function to iterate. The iterate function should sound familiar from the beginning of the video. First, we find the cell with the lowest entropy, which we do by looping over the cells.
By the way, I just realized I'm stupid. I completely forgot while loop was a thing. Here I just did a bunch of random shit here for loop with a break. Yeah. Nah, well, whatever.
To find the one that contains the lowest number of possible prototypes, with some randomization in case there's a tie. Then we collapse the chosen cell fully collapsed. This function simply checks if any of the cells in the wave function.
What are you trying to do? We're creating a kind of hacky wave function collapse.
Still contain more than one entry. If it hasn't fully collapsed yet, we tell the wave function to iterate.
You'll rewrite this in C++? Most likely. I think Blueprint is going to struggle with doing this big loop. It will most likely have to rewrite in C++.
The iterate function should sound familiar from the beginning of the video. First, we find the cell with...
But that being said, literally, the current train car, which we're going to be using, is just a 2x5. It's not a huge piece, so we should be okay until we start doing like dungeons and larger scale areas, right? So
lowest entropy, which we do by looping over the cells to find the one that contains the lowest number of possible prototypes, with some randomization in case there's a tie. Then we collapse the chosen cell by picking a prototype at random from its list of remaining prototypes and remove the rest. Finally, we propagate those changes to the rest of the wave function. So far, so Sudoku. But before we wrap up, let's take a look at how the propagation actually works, as this is the beating heart of the wave function collapse algorithm. To start with, we add the coordinates we just collapsed to a stack, which is just an empty list at this point. Then we head into a while loop that will continue looping as long as there is still a cell in the stack. At this point, we know that there's exactly one cell in the stack, and so we pop the last entry from the stack, leaving the stack empty. Next, for each of the 6 directions, we get the coordinates of the next cell in that direction, along with a list of prototypes currently contained in that cell. Then we can just check what the list of valid neighbors for our current cell is, and compare the two lists. Any prototype in the neighboring cell that's not considered valid is simply removed from that cell's superposition, which is what the constrain function here does. Finally, if a cell's superposition was modified by this propagation, we add its coordinates to the stack, so that it can propagate the consequences of constraining the possibility space to its neighboring cells. This will continue looping in this way, constraining cells, adding them to the stack for further propagation, and so on until the stack is empty. Then, iterate will be called again, and there'll be another round of propagation, and again until every cell in the wave function contains only a single prototype. Then it's a simple case of rendering the result, which is done by looping over the wave function one more time and instancing the corresponding mesh at the correct position and orientation for each remaining prototype. And that's it. Our wave function collapse implementation is complete. As you've seen, the solving algorithm is actually pretty straightforward, and most of the complexity in this example actually came from creating our adjacency constraints. Something I haven't covered in this video is weights, as a way of telling the algorithm to prefer picking certain modules over others. But hopefully after watching this far, you already have a good idea of how this might fit into your wave function collapse implementation. As always, if you
Okay, we need a rotation in here. Is it F rotation? Rotation? U rotation? Guys, what is it? Is it F rotation? What the hell is the... What's the correct thing for this? Rotation. Is it F rotator? Looks like it. Actually, I don't want this to be an F rotator, because we're only going to be rotating on the z-axis by 90-degree increments. So this actually, we want this to be an integer. Which integer was it? That works in 30, was it in 32? We want this to be an integer. Aha. Aha. Um. Okay, sure. Um. Thank goodness I did this correctly. Span X and span Y. Okay, thank goodness. We did, everything's consistent. Everything is consistent. Okay, so we have the level, we have the rotation, X positive, X negative, Y positive, Y negative. I don't know if I'm going to keep track of every potential thing that could be nearby it. I think what I'm going to do as a starting point for me is I'm going to loop over all of the neighbors, or maybe we could loop over the entire thing. Let's try to get the path working first. Let's try to get the path working first. That would be piece number 1 in the system, right? Let's get it to generate the tiles for the pathway. I think that'll be good. Surely our game dev wouldn't overcomplicate a simple generator. No. Don't you need to check so the long block doesn't stick out of the train? Right now, we're not going to use the long block. We will have to figure out how we're going to do that, though. The long block is version 6. Right now, we're at version 0.5. This is going to be an interesting one to figure out. We're just not going to use it for now, I think. Even though it is very cool. And this is going to be on my priority list, is to get pieces like this in. Okay. Simple generator, brother. WFC is like end game boss fight of algorithms. You do this at 60 years old, 40 years of experience in software engineering. I don't think it's that hard. I think I'm just trying to wrap my head around the whole neighboring list thing. I don't understand how that information's. I don't understand how that's being done. So, from what I'm understanding, is the neighbors list is basically. We're recreating PCG in here. We're making our own version of a stupid, like, world function, wave function collapse thing, which is not really wave function collapse, but it's going to be some, I don't know what, some atrocious version of it. First, we need to figure out the path, and then we can figure out the connection points after the fact. Hold on, I'm trying to figure it out here. Pathing is easier to do when you have room solver done, by the way. I think, yeah, I don't know. How I'm picturing is once we have the path, right, if there's any T sections, then it knows, okay, this is a valid place to do something. So it's not even necessarily wave function collapse. It's just choose a random piece, go there, do the thing. Now, doing the long pieces, don't know how we're going to do that. We'll figure that one out. Don't know how we're going to do that one. Let's just not talk about that. Let's not talk about that. We don't talk about the long pieces. They don't exist right now. Okay, so now we just need a place to keep all this data. I guess it could just be a data asset. Either one of two things, a data asset as an array or a data table. I think we want to do a data asset. I kind of want to learn how to, is this a crazy idea, learning how to do like a JSON file in UE? But UE can't read from a JSON file, at least without a plugin. I know there's a JSON plugin out there somewhere. What's the alternative for UE? What's the JSON alternative for UE? Yeah, no, I'm not going to be doing 100% as WFC says it. I'm just going to go with whatever is easiest for me. You guys know how I am. You guys know how I am. Surely UE can read any file and you just translate the data yourself. Yeah, I just don't know what file it can read from. What kind of file it can read from. KISS is the best software architecture there is. Keep it stupid simple. Do you search JSON in the plugins? Oh, are there plugins in here? Oh. JSON functionality for Blueprint. Just use a data asset, don't overcomplicate. Keep it stupid simple is not how it's said, but sure. What is it? Keep it simple stupid? Keep it simple stupid. I thought it's stupid simple. Simple stupid? Keep it simple stupid. Keep it stupid simple. Whatever, fuck you, man. It's stupid simple in my head. I would only use JSON if you want to give users access to the config files. I guess the only reason I'd probably want to use JSON is if we end up somehow using Blender and letting it, just like how he did it here, is generating the open slots via Blender, but I don't know how to do that. Although that would make my life a lot easier, especially as we scale up with more pieces. Unfortunately, I don't have that in my skill set. So I guess we're just going to stick with a data asset. I'll just make a Blueprint data asset. Fuck it, whatever, screw it. Where's the one I'm looking for? Do you guys know which one I'm looking for? not primary asset label. I think it's just a primary data asset. I don't know if you need a primary data asset. Allows it to be manually loaded / unloaded. Like I don't need to unload it. It's all that OSRS and deadlock. What do you mean? I'm fine. Wait, I can't even select the original data asset. It has to be the primary data asset. That's crazy. Random gen data asset. Yeah, I guess. All right, and then in here, we'll have a variable called prototype rooms. We'll just call it rooms. Fuck it. Then in here, we need to restart our code. I mean, restart our engine. I love this part of the job. Am I ranked in deadlock yet? Dude, I haven't played it since I haven't played it. I think all the better for my mental health, to be honest. Would be funny. It would be so funny if Chrome had 2 OSRS instances. That was me the last time I played OSRS. I would have that shit open while working. But listen, I gotta be responsible. We're working. We're on the job right now. So random gen tile of data, and then this is going to be an array. And this is going to be an enormous array. Let's check that everything in here is good. Okay. Now I have to generate every tile, including the rotations. Or not, I just gotta write it down. I gotta write it down. Because I don't have a way of generating those pieces. All right, well, no better time than now to do this work. All right, let's start with the dead end. All right, start with the dead end. So the dead end, I don't even know where I'd get started with creating a generator for this. Like if I were to like automatically determine these pieces rather than doing what I'm doing. All right, well, let's just do this real quick. I can't drag the window. Thank you. Okay, so dead end. X positive is 0, X negative 0, Y positive 0, and Y negative is 1, because that has a doorway. Now we just have to do that 3 more times for just this one piece. I might have to make a tool for this. There's no fucking way. So the rotation would be 1. Y negative would be 0. X positive would be 1. Okay. This would be rotation 2. X positive is 0. And then it would be Y positive that would have a 1. So let me see here. Is there a pattern here? 1, 1, 0, 0, 1. Huh. Not really. Okay, and then the last one, which is down here, it would be X negative would be 1. Y positive would be 0. Is there a way I could generate these pieces by push-ups, huh? While I'm like deep in it? Jeez, man. Tough crowd, even on a weekend. It's crazy. Pattern is that one moved position each time. Yeah, okay, we get that part, but like, come on. You know what we could do is we could use line traces and then it adds an input each time by rotating it 90 and then doing a rotation. Order your rotation so you just move the 1 by 1 position. So that would mean... This starts at Y negative as 1. Whatever, man. Oh, whatever, dude. All right, so we got these. Now we have the straight. Luckily, straight tight is the exact same as straight, so I just gotta copy the thing. I just gotta change the level. So I could just, for the corner piece, I could just copy the same one as the other corner piece. Yes, dude. We're so in. Okay, so straight, rotation 0. We have X positive 1, X negative 1, Y 0, 0. For the rotation, okay, which we only have one rotation of, it's just 0 on the X and then positive on the Y. Yes, dude. Okay, and then we can duplicate this for the other straight. Duplicate that. It would appear I've inversed that. I'm stupid. I don't know how that happened. There's another guy. Kubernetes sees he has 4 indices per object, so he doesn't break the array. All right, so we got straight, tight. Good stuff. We got this one done and this one done. And then we got the dead end. Now we got to do the corner. The corner. Okay. So I'm really not looking forward to figuring out how we're going to generate these big pieces. I guess the big piece, we might have to... Oh, shit. I might have to redo this. Or we make an array that has additional tiles. Call them extensions. Is it already time to remake? Listen, man, we don't got time for that. Okay, so x positive 1, x negative 0, y positive 1, y negative 0. Duplicate. Add 90 degrees. This is rotation 1. X positive 0, x negative 1, y positive 1, y negative 0. Okay. We're 100% gonna have to figure out how we generate this because this is insanity. So x negative is still 1, y positive 0, this becomes 1. Yeah. Y negative 0. X is listen, man. What? Just get with the contract, man. 0, 1, 2. Why not do this in QPU? Would be a nice challenge. Well, it would be good to make a system that just does this for us. That was a pun on y negative 0. I know. That's why I stopped reading it. It pissed me off. So we'll duplicate this. It doesn't go to the bottom. I want this to go to the bottom. Corner tight. Duplicate this one. Corner tight again. And then we just need 2, which is the last one. Doing this by hand is kind of psychotic though. For real. It do be kind of psychotic. This is some shit some psychopath would do. My brain hurts, Krim, and I'm very concerned. Guys, it's very simple. We just specify rules, right? And the rules are, if it's 0, it's a fucking wall. If it's 1, it's a door. That's it. I mean, do the generation on the GPU using compute shaders? That's not happening. That's not happening. That's not happening. That's not happening. Is that all of them? No. We have corner. We have straight. I think this last one is the T connection. Oh, great. This one's going to be a lot of fun. So, x positive 1, x negative 1, y positive 1, y negative 0. Can you add this emote? No, we already have one like this, I think. We have a emote that's kind of like that. I just don't remember what it is. X positive 1, x negative 1, y positive 0. And then I don't think we need a third iteration because... Never mind, it would appear we need a third iteration. Sir, a third iteration has hit the board. So x positive, x negative 0, and then this one's 1. And then we check all of these are different. Yes. Okay. Is that it? Is that all we got to do for the data? As far as I know, that's all we got to do for the data. Waiting on the array out of scope error. Oh, no. The thing that will hit us, most likely, is a infinite loop. Because Blueprint has a limit on how many fucking loop iterations we can do. 100% we're probably going to be hit by an infinite loop. Okay, so path solving, start and end goals. We need to specify what kind of piece it needs to be. So we could do a map. Please hold, my whole UE is going. So we do an integer, and alongside that, alongside the map, you can't replicate a map though. I might just make a struct for this. I don't give a fuck. This is the kind of blueprint you make when you AFK fish on the side? No. This is the kind of blueprint I made while AFKing sailing, actually. While doing salvage. Actually, I was doing salvage, which is kind of like fishing, if you think about it. It's on the sea. This is some PoE2 skill tree. It's not that complicated. All right, do you want me to explain it to you? Please try. Okay, so we run the generation. First, it clears out everything, so then we have a clean base to work off of. This then adds the little green spots, the barrels for the start and end positions, which are just index values. Okay, and then we go through a huge loop, humongous loop, huge. Okay, we keep track of the past path point and the current. That's so we can do the little lines to debug which direction we're going. Then it just checks, okay, is the path point at the end of the row? Wait, hold on. Let me open up the level. This will be easier to explain. It then determines, are we on the column that's near the end? Okay, right? And then it'll do different stuff. If not, okay, let's do some other stuff. This is going to check for backtracking. We can ignore that because we don't do any backtracking for our normal thing. This will then choose, do we go up or down, up/down, or to the right? Okay. Basically, we do two checks. This checks, can we go up? Or this checks if we can go down. This checks if we can go down. It basically checks the tile below and then checks if it's valid, right? So it does two things. It checks this, and if it's less than the span, so not out of bounds, and then it checks if there's already a path there. If there's a path there, we don't do it. Then this checks if we can go up. So this minus the span more than blah, blah, blah. And then it checks if it's taken up already. And then it does a random chance. So there's a random chance of it going up or down or to the right. This will then set the actual index that we want to go to. Or if we go to the right, it's as simple as just doing +1 because these are just index values. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? That's it. Then we just added a little debug barrel and draw our line to determine the direction that it needs to go. That's it. That's it. It's that simple. It's literally that simple. It's that simple, baby. Thanks, I copied it and released Trainrot 2. Mods. Okay, now we have to determine how do we read from the data asset to do the rest of this. Um, damn. What kind of asset is this? A primary data asset. What did I call it? Random gen data? Rand? Why isn't it in my list? Is it because it's blueprint? Can I not read from it because it's a blueprint? That's only a class, not a data asset instance? Oh, here we go. Oh, wait, you're right. Oh, shit. I think I'd have to create a data asset from that blueprint. Ah, whatever. We'll just read from the class, right? Right? That's fine, right? Although I guess if we wanted different kinds of rooms using the same kind of system, I did accidentally change the defaults of it though. But sometimes you make a couple mistakes and all right, fine. Yo. Okay, so we're going to want to create a data asset. We'll call this train car rand gen data. Please tell me it still has the array that we painstakingly made. Thank goodness. Okay, now we have the thing. It's in the thing. This means that we can choose different kind of data assets for kind of different, you know what I mean? Yes. If we have like different meshes. Yeah. This cool super hire video popped up on my recommended. Guys, absolutely correct. Oh, Swifty? Yeah, yeah, yeah. Yeah, dude. Hashtag import brain cells. You got it. Failed to import. I don't know what the error code would be. For your info, YouTube chat failure on your overlay again, Krim. Hashtag lazydev. Fist. That's because no one has messaged in YouTube chat since we started. Not because it's broken. It's because no one has posted anything. See, there's the first. Wait, is YouTube chat alive? Maybe my shit's just broken? Wait, hold on. Oh, there's Alec. Once I found the game, it's all Algo wants to share. Suit for hire? Really? No way. It's me. I'm the YouTube. Alec is the entire YouTube. The entire of YouTube. Okay. So now we have the data. Although I think I'm missing a part of what makes the wave function collapse a wave function collapse. Also, I'm a little bit concerned. I know we have the U world in here. Isn't it supposed to be a soft object pointer? That doesn't look like the icon for a soft object pointer. Hold on. Okay, it is. We're fine. So it's not going to load every single level right off the bat. Stop focusing on thinking you've done wave function collapse. I know, it's not wave function collapse. It's like the stupid version of wave function collapse. It's not even the wave function collapse. Okay, so the start and end goals, we need to define which direction we 100% need in those areas. We could just reuse the random gen tile data in here. So just so we can use this. Just so we can quite literally just use this. Which is why I was thinking a map would be a good idea. Ah, whatever. Just fuck it. Do a map. Do a map. Because now I'm going to have to fix all of this fucking shit in here. Oh. Just so we could do this. And then we're going to set the default 0. I can't add another map. 0. Can I put this at the beginning? No, I can't. I guess I'll go fuck myself. That means anytime we do a get, I got to change the value of it. I'm mad. Mad. I'm mad. I'm mad. I'd be mad. Where else do I do that? Oh no. Oh, come on. What the hell? What the hell? That's not going the right way. Wait, hold on. Wait, what the hell? That's just not going the right way. Wait, no, wait. Oh no, I'm going the wrong way. I'm stupid. Whatever. I'm the idiot. I was plugging into the wrong thing. It's like plugging a fork into an electrical socket. I'm so stupid. All right, let's see if this still works. All right, good stuff. So, the beginning point needs x negative to be 1. So that's why we did this. So we could say, hey, x negative needs to be 1. The other values, it doesn't matter. We'll just leave it as empty. Is that okay to do? We'll just leave it as empty. Wait, no, that's the ending point. Oh, shit. Damn it. The beginning point needs x negative to be 1. The ending needs x to be positive 1. I guess I could have easily just determined that based off of whatever. Okay, let's start with this. We need to generate the very first tile. Let's just do that first, right? Okay. Haha. Yeah. We've generate the first tile. Okay. Okay. So the first tile. So okay. We need So how are we going to do this? So would it be a array of arrays? Can we do an array of an array in Blueprint? No, it'd have to be an array of a struct. How did we do it for the data set? We could do another map. Could we do another map? I guess we could do another map. We'll call this the boom. The nice thing is the random generation only needs to happen on the server, because then it'll load the level instances, and then the clients will receive those level instances. So like that won't be a problem. So we don't need to replicate the maps at all. I just don't know how to name this. Tile. I did hear someone, there was a term called like prototypes. What are prototypes? Are prototypes the modules? All prototypes dictionary, all prototypes. I also see coordinates. Let's call it tile options. No, let's do coordinate options. Coordinate options. Yeah, sure. Future me will understand this. Yeah. Yes. Yeah. What I want to do, which I think would be really interesting, is put a little debug text. So, okay, how we have to do this. I guess we really don't need to do it this way now that I think about it. What we'll do, let's make a branch here. Let's create a Boolean, create tiles. So this will be our way of determining, hey, do we actually want to generate this stuff? We'll say by default it's false. So if this is true, also, do I technically need this beginning point? Oh, it doesn't create one at 0. Ah, I see. Oh, because it just adds the first. I technically don't need this because you can even, oh shit, whoops. You can even see that it's creating the end piece. We just need the beginning part. Is there any debugging for blueprints like breakpoints, etc.? There is, yeah, totally. Totally. So I guess we could do a sequence. This could be the first tile. Choose the first tile. Okay, this is where it all begins. Okay, wait, no, wait, hold on. Because if it selects the path, we need to know ahead of the time where is it going to go next. So actually, what we're going to be doing is we generate the next tile, and that will determine the first tile. Oh my god, look at this fucking code, man. It looks like a brain. It's like nerves. A nervous system is spawning out of my fucking random generation manager. So this determines the last piece's location based off of which direction we're going. We do need that. We need that variable I created. Coordinate tile map. Generated tile map. So basically, when we create a new instance, this is going to be the first level that it selects based off of parameters. Okay, let me see here. How do I do this? We need to determine if it's going to be X positive or Y positive. And it needs at least 100% one of those. So what we could do is have another variable in here called required current required tile. And this could just be a single with the random gen data. What we could do here is say, hey, set this to the very first one. Set the data of this to the tile, the start and end goals, which by the way is now end and start goals because you can't sort a map for some reason. Why did I have to do it this way? Why did I have to do it this way? Why am I so stupid? Okay, so then we want to get of 1. We're going to split this, and this is going to become the beginning rules. Okay. If it's like a C++ map, it's already sorted on insert? I don't know. It's a really good question. I don't know if it is sorted, actually. If I hit the play button, is that gonna... Am I gonna notice this shit breaking? Well, I'll never know. Because I literally can't tell. Because the debug arrows don't appear. Ignore that. Let's just assume it's fine. And it's not actually sorting it. Because if it is, then these get values are going to be incorrect. They're not going to be right. They're not going to be right. Okay. Trying to wrap my head around this real quick. I like the idea of doing what wave function collapse does, which is you have an array of the array, which is each map basically having a dictionary, or like each thing has its own thing, and then you're basically just selecting potential tiles that it could use, and then it just randomly selects one. I do kind of like that. I feel like I could wrap my head around that. Because right now what we're basically doing is I'm going through the data asset every single time. And wait, are you for real? Oh, because it's a primary data asset. I'm so fucking stupid, man. Do this instead. This will make my life so much easier. Because then I can just do get rooms. This is going to be very unoptimized. That's okay. We're going to learn. We're going to learn. Because what I'm going to do is we're going to filter through the entire room list every single time. Every single time that we're doing this, we're going to filter through the list. For now, I'm going to slap a do once in here. The reason for that is because I just want to generate the first tile, just to see if it is doing it correctly. And then we can go from there. So we'll create a new function called select next room. Okay. Generate a tile map. This is going to be interesting. Generate a tile map. Current required tile. So current required tile is the one that is first beginning and needs those openings. Okay. Then here we're generating the next instance point. Gotcha. So we would create the so we would select the next room. The output of this would be the room to use. That would be selected room data. This would be random gen tile data. This would then do a for loop create a local variable. This is going to be room pool. Current room pool. So it's going to first create this. Then we're going to, what's the word I'm looking for? Shuffle it. We're going to shuffle it. And then we're going to do a for each loop of the current room pool. And we're going to at the very least, check if the x positive, x negative, y positive, y negative, if it at least matches one of the values in current required pool. I'm starting to think separate string values was not the way to go. Because how am I going to check this? It would have to contain so one of these need to be equal exactly, or empty. Hold on, I'm trying to see if this is correct. Because when there's an empty tile, which is what we have here, that just means it could be anything. Let me think. It's equal to the thing or empty pass. Okay. Okay. Check adjacency is adjacent do just a pure call. Dude, I don't know why I hate when it does this. Required checking, and then we need a Boolean output valid. This is gonna get pretty gnarly, but that's okay. We're gonna see if this works. So checking is not correct here. Checking would be this one going here, and we would be checking that one. So we would check all 4 of these. I don't know if that's correct. All right. This is how I've wrapped my head around this, at least. It's either it's empty. It's either the required one is empty, which means it could be anything, or it fits the bill. So all of these need to be in the and. This and this and this needs to check against all of these. It's a bit psychotic, but could do the trick. So if this passes, and we've already shuffled it, then that means this could be the selected room. And then we'll just return node and go through it. Now, if this completes, that means we were not able to find anything. So let's do something like this. Just as a check. Okay. Is this basically the gist of WFC? Is it's checking if the required tile... I don't know if this is true, because I feel like there's that whole like neighbor tile array thingy that we saw, and I don't know what that was. I don't know if they're saving literally every single option possible inside of that array rather than like trying to do this in runtime. I have a feeling that's what it is, but I don't know. I don't know. I don't know at all. I don't know. We got that. So we select the next room. So create tile instance. Let's do select valid room. So because we're only doing this once, we can just read off of the first required tile data. Selected room data. First we check if it was successful. We broke. And then in here, we don't have to spawn the level yet. We're just going to break the generated data and then object to string. And this will at least give us an idea if it works. Is it because it's the do once? Can you not put a do once in a construction script? Wait. It would appear I cannot put a do once in the construction script. I'll just put for now, just because I only want to spawn one. Length less than or equal to 1. This should at least only give me 1. What? Oh, 2. It has to be 2. Oh, fuck. T connection. Okay, I would love to slap this in here. My only problem is I need to delete. I would have to delete. Okay, so let's do create tile instance. No, we're gonna do this one to create the tile instance. Let's start adding in the level instances. Surely this will be just fine, right? Let's make a thing called level instances, and then this will be a level instance because we need to destroy them when we don't need them anymore, right? So let's do can we even, are they considered actors? I guess we could just destroy them. Destroy, delete. No one really knows why they called it wave function collapse, because in quantum physics it describes how we don't know what the fuck is going on. No, that's why they called it that, because we don't know what the fuck is going on. That's exactly why they called it that. What about pact level actors? I didn't do enough research into pact level actors, but I felt that that this was kind of more than enough. And I also use level instances for the other parts of the train. So I'm kind of just like following the same kind of ideology with this one and seeing if it works. Okay, compile, save. Oh wait, shit. Unplug that really quickly. Add. This is a level streaming dynamic object reference. Level streaming dynamic object reference. Level streaming dynamic object reference. How do we unload a level instance? Okay, I didn't plug that back in. Let me see what I can do. Maybe we can remove it. I think you can unload it. Yes, I think you can unload it. We do that with the trains. Hold on, let me see here. Hello, Chan. How's it going? Hold on. We can do that with the trains. I know we can because we've done that before. I already got past this step. I already got past this struggle. I think it's in the game state. I think it's in the game state where we unload all the trains. Server transition to station? It's going to go through everything. It's going to set request unload and removal. And I believe that's the same one. Yes. Okay, so now we do the dangerous thing, which is plug this bad boy in here. Okay. We're just gonna make this only spawn once. That's not correct. But that's, wait, actually, no, as long as there's a doorway here, it's correct. So far, so good. Okay, so now we just need to tell it. Okay, so now we just need to tell it which the additional doorway that it needs. Okay, so on top of just doing this, which is defining the first door, we need the second door, which is the continued door way. The door. We need the door. We need the second door. We need to determine the second door. So we got the first door, but now we need the second door. So the second tile, we have the first tile. Now we need the second tile. Okay. I think we can actually do this. I think it has to be 2, length 2. Because that means it's the second piece. Although this seems to happen quite often. Whatever you do, do not move the construction script. Apparently that's... I don't like that. In fact, I'm going to make this so this does not run on drag. Why did it duplicate? Okay, so the next piece of the puzzle, we need to tell the thing, hey, which direction is the next piece? Like, which way is the door supposed to go? I guess we could just do that here. Choose if we go up or down. Right here, and then in here. If this goes to the right, that means the value needs to be x positive plus 1. The start and end goals is x negative 1. Well, you know, I guess we could do that, yeah. Set by reference. Or no, I need to set just a specific set of member. X positive will be 1. Or actually, we're thinking... Are we thinking ahead or are we thinking... No, we're thinking ahead. We're placing the tile beforehand. So x positive 1. Dude, why does this keep... Oh, dude, this is going to be really bad. We're going to have so many random pieces. Okay, so this will determine if we need to go to the right. Then we need to determine if we're going up or down. Okay, this is really stupid. This is dumb. I know this is dumb. This is fine. That's fine. Sometimes you just gotta do it your way. You know what I mean? All right, so we do the current path point. We do an and here. The problem is then we set the value, so we can't read from this. I can't just do this because it's going to have the wrong thing to determine if we go up or if we go down. What is up in this case? Y negative is up. Right. Right. What if we just do the inverse of this? If you do the inverse of this, no, that's not a good idea. We should probably save this. Iteration going up. Minus span x. Yeah, I think this is going up. So if going up is true, which is y negative, that's 1. Otherwise, false is 0. And then y positive, this becomes 1, this becomes 0. I don't know if that's actually true or not. You know, I don't think this is a good idea. In the case of having a tile piece that just has 2 tiles, it's okay, but it's working. That being said, it is giving us a value up here. So we then need to determine if we are within the, if we're on the boundary edge. But it is now doing the first tile. Now we just got to do the next one. And all of them after that. And then the ending one, which is going to be quite important. Okay. So now we just generate the rest of them. Well, what's the worst that could happen, right? It technically should generate the right locations. Dude, I don't know why it creates all these like dummy. That's something I gotta figure out. Why is it creating all these dummy pieces? An array of each square would contain legal directions that contain a door. Right. So that was initially what I was thinking of doing is we just outright do what I think WFC does, which is every tile has every option already attached to it. And essentially, we can already filter all of them from there and then choose the pieces from there, which is probably honestly better than what I'm doing right now, which is I'm filtering through the thing dynamically over time. Little chaotic. Okay, so let's see. So this piece goes there. Okay. So the first one always generates correctly. Now it's just about the next few pieces. I am noticing, however, funny enough, that the last one is not generating a tile. Why is the last one not generating a tile? Oh, because we're always doing just the past one. Your blueprint is clean. I don't see any spaghetti. It's just a lot of numbers, man. It's just a lot of numbers. Okay, so our current problem right now is we need it to generate the last piece. I don't think this is correct. Like the doors aren't generating correctly. That's okay. We still have to figure that part out. We haven't figured it out. Let's do the next thing, which is detect boundaries. Your Floyd layout would be a little efficient in data entry if you have 1 to 10 contain their data too. Oh, I guess we should just generate all of the potential tiles that it could be in. No, it should be... If I turn this off, will it delete all the pieces? Good for me. Okay, now I gotta delete them manually. Of course, yeah, right, yeah, totally. We also gotta figure out why the last piece doesn't get generated. I think it's because we're always generating the past path point. And we probably are missing one small iteration at the very end. So let's determine the walls. We can do that by reading where the past path point is, because we're generating this based on the past path point. This is really stupid. This is kind of stupid. This is really stupid. Okay, let's just set up the boundaries next. That'll at least thin out some of the doorways. Give me 1 second. You're a tweak. How you doing? How you doing? You know. You know. Just stuff and things and stuff and things. You know, stuff and things. Okay, maybe we just write this somewhere else, and then I write it in the thing, and then that way I can at least know. Yeah, I'm starting to think maybe we, because technically speaking, the generated tile map would give us the past door, like where it was. I went to the couch store, we put together a couch we liked, they calculated the price, we paid it. They said, congratulations with your purchase. Why do they congratulate you? I don't know. Congratulations on finally picking a couch, you motherfucker. The next time I buy a couch, I'm 100% going to try it. I'm not going to choose any of these fucking internet couches because that's the mistake I made, and it's just not comfortable, dude. It's not comfortable. It's like I paid for it. You sell couches. Why congratulate me? You should have been like, congratulations on the sale. Congrats on the sale. Just sit on the floor like a man, Crim, fist while he goes to the doctor and be like, why are my ass bones fucked up? What's wrong with my ass bones? I've completely crippled them. Okay, so we need to determine if the point that we're about to create what if we do it in here, actually? Select valid room. Let's do filter filter room tile boundaries. Filter tile bounds. Yes, dude. Okay, there we go. Okay, there we go. There we go. There we go. There we go. So this will filter the tile bounds before selecting the valid room. Okay. So here's the idea for what this is going to do. Basically, we're gonna read if we're on the top or if we're on the bottom. Where do I use C++? Is it mostly blueprint heavy? Mostly like with creating structs and whatnot, but I think this code, we're definitely gonna have to bring it in C++ once I figured it out in Blueprint. It's just a lot easier for me to figure it out in Blueprint for me. My brain doesn't, like figuring out how to write this in code would kill me, I think. So doing this here is just a lot easier for me to grasp, and then I can figure out the rest after that. So we don't really care about a required path ahead. I think what we care about is this one and this one. So this is just for the top and bottom, which would be y positive and y negative. And then we don't want current path point. We want past path point. Logic and math is so much easier in C++. For you. Maybe for you. I don't got that kind of brain. My brain don't work that way. My brain works with wires and spaghetti and boxes and shit. What you working on anyway? I'm working on like a procedural generation thingy. It's like doing logic in Factorio. Man, I could not get into that game. I could not get into that game. So what we want to do is check. I guess what we'll do is we'll just do this. We'll do a branch. Let's do a sequence. So at the moment, this just determines the boundaries of the top and bottom. We're going to have to also determine the boundaries of left side and right side. Yes, I'm doing it with if statements. I don't give a fuck. I don't care. I don't give a shit. But you can code it better. I don't care. Suck my balls. Aha. So this checks if the bottom is valid, which would be y positive. This would say, hey, 0, not valid. This one would check if going up is valid. If it's not valid, that would be y negative would become 0. And then we'll have an ending point here, which is going to be our return node. Okay, so this should now at least generate, each tile should, okay, it's not going to generate properly, but at least the first one will. Crim did it again. He overcomplicated something that could be simple. What do you mean? What a puke. Okay, so now at least this beginning part should not ever have a wall going up. I don't know if the other pieces will work, but it kind of seems like they do. The thing is, this is kind of cheating because first it's actually, no, it's actually working technically because that piece has an up. This is for the random generated dungeon parts of the train. So we've created a new train car that's kind of randomly generated. But this is hand placed just to kind of get the feeling if it's actually worth investing time into. I felt like it was really good. So now we're just creating a randomly generated version. And then we'll obviously reuse a lot of this code for the actual randomly generated kind of areas as well that we might have throughout the game. So I don't see why not. You know, why not? You know, why not? I'm very curious if I increase the span of these things, if it's going to work. I don't think it will. So 0, 1, 2, 3, 4. 0, 1, 2, 3. If I do span Y there, does it start? Oh, great. Oh, great. Oh, great. What up, Alec? I'll switch to Twitch. We have music here. And emotes. Okay, one part that's really annoying. Even though I'm keeping track of the levels that's being added in, they're not all deleting properly. Okay, now the next piece of the puzzle. The connected walls need to be connected. What's the idea that'll add to the gameplay, the randomness? I think the randomness keeps that element of suspense there. It keeps that mystery there. Whereas if you have a car that's like, for the most part, always the same when you walk in, I think, at least from a developer standpoint, I could already tell like it loses that that thrill aspect of not knowing what's around the corner kind of thing, like what the space might be and whatnot. Because I feel like knowing the space is a very big like horror element. If you know the space, then you know where you can run to, where you can hide. Whereas not knowing the space and where you can go, I think creates a much more effective mood. I don't know why it's selecting the same car every single time. You guys notice that? When it goes across, it's not like randomizing itself. It's just doing the same thing over and over again. Oh, that time it didn't. Like, we have so many more T junctions to be doing in here. Pseudo RNG, it's kinda... No, it should be random, because what we do is we select the tile by shuffling. And then we filter through the rooms to determine which one's valid. So we shuffle every single time. Is shuffle in UE just not a good node? Does this shit just not work? Let's do this. Shuffle from stream. We'll do this instead. And I believe we use that right here. And maybe this will give us a little bit more randomness using like the thing here. Oh, great. Now I gotta delete these. Also, something very concerning. These do not seem to be adding themselves as level instances. It looks like they're kind of just adding themselves as static mesh components, which is a little bit concerning. We might have to give them, when we generate the level instance, we might have to give them a level name override. Do you know the definition of insanity? Doing something over and over again, expecting a different result? It's fine. Listen, I'm not expecting a different result. I know what's going on. Optional level name override. So we should probably name this something. Because I think this would help, having an actual override value there. Let me turn this off really quickly. And then we need to come up with a name for this. Making the same mistakes over and over again without learning? Well, no. Insanity is actually making the same mistakes over and over again and expecting a different result. It's not necessarily not learning from it. You might be learning from it, but you just might not be applying it. In this case, I'm just hitting the random generate button because I think it looks cool. I just think it looks kind of cool. It's just, that's it. I'm not expecting a different result necessarily. Okay, so level name override. Let's do this. We will take the required path. We'll get the length. And then we'll append. We'll do random gen, and then we'll slap the length in here, and then this will at least create the level name override. And I'm very curious to see if that's going to make them actual level instances and not just static meshes. They're still just static mesh actors. Like, I notice it's an instance, but I'm concerned because they're not attached to a level. Whoa. Oh. Sacrifice meaningful experience to get to a point where it's rolling the dice for a fun hit each time. You just grind away, but don't really get that spark within the level, but your game can get away with it if you rely on it being a systematic game. It is a very systematic game in the sense that a lot of the systems will kind of interplay. I think every time we do a random generation, what is load as temp package? I'm very curious if that's maybe what we want. But then again, it's doing this again all over again. It's also doing things in a very weird way. I don't know why there's 2 tiles over there. Okay, so assigning a name. Let's try this one instead. Level streaming level instance. Uh-oh. Okay. Every time I crash from editing a construction script, I'm always terrified because last time that happened, my project stopped opening anymore. So I think that's just because the level name override broke. See, there's still just the mesh, which is very weird. It's like a level instance, but also not. It's almost like just spawning just all of the stuff. Oh, it reset itself back to level streaming dynamic. I really hate how when we do that, it doesn't delete all of the tiles. Okay, let's try setting it back to level streaming level instance. I'm curious. No, that seems to break it. That's probably because... Yeah, interesting. So you have a Git repo? I have to submit. I haven't submitted it in like 2 or 3 days. I got to do that. Usually good balance is handcrafting segments and allowing the system to place them randomly. It's a big challenge with making them where they can connect properly. Yeah. The thing is, we're going to have a blend, right? So we've got the handmade areas like the library and whatnot. I think we're going to still try to introduce some element... I'd like to introduce some element of randomization in those, but they're still kind of handmade to an extent. Okay, so let's bring this back to span of 2. Great, now I have a bunch of these that I need to delete. Okay, this is ass. I don't know why. This is a game dev stream? Yeah, something like that. Yeah, something like that. Like a podcast stream. Yeah, we definitely have some handcrafted segments, but that being said, I think the handcrafted segments get very old very fast. That's, I think, my big problem playing through the levels. Now, of course, we just need more monsters. The maintenance tasks need to be a lot more impactful. We need to add more of them in each of the areas. There needs to be more diversity, I think. But yeah, okay, so Now we just need it so each tile knows what the other past tile was, and then that will basically tell us. Oh, God. I think there's a better way we can do this. A way that isn't as, like, kind of guessworky. Yeah, I feel like there is a way better way of doing this. I do feel like there's a way better way of doing this than the way that we're doing it right now. Build the cars in matrix X and Y values and to populate every square but with only one valid path. I think we should do it the wave function collapse way. I think we should do it that way. And by that, I mean, we populate every single tile with just the root data set, which is all of these rooms. And then we filter out the ones that they can't be. We filter out the ones where we need the beginning points, beginning and end points. Right? And then from there, we can figure out the rest of it like that. Like, I think that's honestly the best way of doing it. I don't like this. I don't like this way of doing this right now. The way it's being done right now. It's a bit hacky. Your method won't produce dead ends. It will create dead ends. Oh, great. This is also really annoying how it just... Okay, before we continue, let's find a way of making it so these meshes don't do this. Because it's actually so annoying having to keep deleting these things every single time we're generating. Do I have to create like a transaction so that it can revert it? Can I not start a transaction here? Transact. Oh, begin transaction. Yeah, what the fuck? Begin a new undo transaction. Manage an undo transaction. Okay. Transaction, end transaction. Because then this way I can just undo this. Random idea with dead ends. Make C4 as an item and put destructible walls and dead ends where they can choose to blow a path in. Oh my god. I don't know how... Well, actually, I know how we could probably end up doing that. Is... Yeah, like we could. Like we could definitely do something like that. That is, as long as these tiles stay as dynamic, which I don't know if they will be. Can I undo a transaction? Cancel the current transaction, no longer capture actions to be placed in the undo buffer. Yeah, but does, okay, end transaction and cancel transaction seem very, very similar. Super random, I think you'd love the Machine Party soundtrack. Okay, I'll take a listen in a bit. I'll take a listen in a bit. Is it a lot like the music he made for the shotgun game? Or what that was made for the shotgun game? Kinda? Okay, okay, okay. Yeah, I think we're gonna change the system. We're gonna change the system. We're going to keep track of every single tile at the very beginning and their potential options, and then that's what we're gonna do. So what I might do is I will submit this right now as version 1. And then if we fuck up too much, then we'll just revert or something. You can tell it's him, but it's a bit of a different genre than techno. Okay, hold on. Let's see it. Let's see it. I'll take your word for it. This is just the Binding of Isaac? What do you mean? What are you talking about? This is literally not the Binding of Isaac. I don't even know what you're saying. I gotta remember to not submit the doors. I think the doors are in a different change list, though. It looks like it's a part of a different change list. And while I'm here, I'll also get latest. Ah, the door cubes. Yeah, dude, what a blunder. Why is it taking so long to submit the files? This is actually oh, no, that's fine. It's really slow right now. I think my server is slow as balls. I don't know why it's so slow. My UE's not open. Weird. Okay, so get latest. Great, I just got latest on the doors. I'm gonna freak out. I think this was 5. And this one was 2. Okay, hold on. All right. Rerun. But now what we can do is we can change the code, and if we need be, we can always revert it back to the old version. Kavinsky? I think I've listened to a few of his tracks, yeah. Passed away recently, right? All right. So what are we changing here? Can I really not solve, like, this map is really annoying. I think we're gonna have to make a different struct for this anyways, so that's okay. Okay. Oh my. So I think the path selection is going to be the same. I think. Start and end goals. This is kind of annoying. This thing here is really annoying. You know what we can rename this to, actually? Start and end goals. These could be... they use a terminology for this in creating these random generator stuff. The constraints. Constraints. Yeah. So this could be constraints. So we can rename this to constraints. And then we're going to need a new struct for this, which is making me think that maybe the struct is going to have the x positive, x negative, y positive, y negative. The problem is if I override this and change it, well, here's what's going to happen. All of the variables that we... Never mind. Just leave those there. We're just going to make a new struct for this, though. And then we'll just copy this. It's that simple. X positive, Y negative, Y positive, Y negative. Yep, I think that's about it. Did I create the trainer project as C++ or Blueprint based? C++. C++. Or no, I think Blueprint, and then I immediately converted it into C++. Which is kind of similar, but not really. My writer doesn't debug my C++ code for some reason? Oh, I have no clue how to go about fixing that. The constraints are kind of annoying because I guess we just create another struct here. I think we're kind of abusing structs a little bit. F random gen constraint. So this will be the index. This will be tile index. And then again, we'll copy this. Or actually, no, we won't copy that. We'll do this. I hate when you hit tab, it does it. I don't know why. F rand gen adjacent rules. Yes. Okay. Okay. Yeah, sure. Whatever. Sure. Whatever. Fuck it. Now we got to rerun. Yeah, I don't know. I don't think I've ever debugged C++ code yet. Or maybe I have. I don't know enough about C++ to say. Okay, so we're going to do a little bit of cleanup and changes here, which means some of our stuff is going to break. So let's just try to make everything work with our new stuff. The constraints are no longer going to be a map. It's going to be an array of constraint. Random generation constraint. We're then going to get a reference. We're not actually going to do this anymore because we're going to do that differently. This needs to get the second value. And then check the tile index. So we'll set 2 in here by default, 0 and 4. Wait, there's no way this is the only one that's needed. It is. Huh? What? Okay, well, whatever. Generated tile map. So, okay. That's not generating, good. Filter tile bounds, good. Okay, here we add required path. 0, right? Yeah, Sky. I got a small question. I work a lot in UE 427 and even editor. I had non-steps 120 FPS, but in Unreal 5 and the editor with Lumen, I often just have 70. Even if I set the old model of none and screen space reflector, I just what could that be even in an empty mask? I just feel like I missed the 120 FPS in UE 427. DX12 probably, Sky. So you can try switching your project to DX11 and that'll probably be very close to what UE 427 is. It's probably going to be a little bit lower than UE 427. But that would be the first thing I would do. Disable a bunch of plugins and stuff that you don't need as well. Etc, etc. But it's not going to be 100% the same as UE4, but it will be closer. Yeah, I removed all of that. I disabled all of that stuff. So if I go to my rendering, yeah, disabled all of that stuff. Just regular shadow maps. Lumen, I didn't edit anything in here because it's disabled. Allow static lighting. FXAA. And then Lumen is disabled and all that stuff. Okay, iteration going up. So I think Let's see if we have to keep this. I don't know if we're gonna want to. I don't think so, but current required tile. Generated tile map. How do I so we just need the x positive, x negative, y positive, y negative. Oh, right. We wanted to make an array of arrays. So I actually think I did this wrong. Whoops. Oopsie. Because what we want is an array of this. A struct of an array, which is this. Because that's the only way we can do an array of arrays in Blueprint, is we make a struct that contains an array of the struct. Don't ask me why. Why did I do this? This is not what I wanted to do. Let's just do it this way, I guess, then. So use struct type struct f random gen tile prototype. I'll just use the prototype word that they've been using. I don't think it's in the correct context, but is this already verse? No, this is C++. This is C++. So it's funny, the struct literally just needs an array of the random generated tile data. How do you create an array? This was it, and then tile data. I believe that's literally all we need to do. That's basically it. I don't know why I did these other things. Kind of unnecessary, but why do I create my structs in C++, by the way? I feel like they're a lot more stable than Blueprint structs. You have a much lower chance, I think, of breaking your project suddenly. Whereas with Blueprint structs, if you start editing that struct way later on, where it's like edited in a bunch of places, I feel like it creates so many issues, especially in UE5. In UE4, it was okay. It still created issues once in a while if you weren't careful. In UE5, I don't know what it is. I think it's like hell on earth. Scorched earth, baby. It's not good. Not good. Wouldn't do it again. So now I just make all my structs and enums in C++. It's the one thing I'll at least use C++ for. So this will be, so instead of generated time map, we'll call this the prototype map. We'll just call it prototype. It will be a array of prototype So every array will have an array. Yes. Every array will have an array. Okay? Catch what I'm putting down? So the very first thing we'll do... How deep does this rabbit hole go? No, we just need an array of an array. That's it. We just need an array of an array. That's it. That's it. We don't need to go any further than that. Don't get too crazy, okay? We don't get too fucking crazy. Okay, so I'm going to write this code somewhere else just to get it in. So we want to add a value. We're basically creating, so span x multiplied by span y minus 1. Then we do a for loop. And actually, let me check. 5 times 2 becomes 10. We want it to be 9 because it goes 0 through 9. Okay. This will essentially... So I'm doing what, at least from what I understood, how WFC works. So it's going to read from the room data set, rooms, and we're essentially going to add, we're going to split this, which gives us the tile data, which I should have called rooms. Could I still call it rooms? I guess we could just call it rooms instead of tile data. Because tile data is incorrect, so we're just going to rename it to rooms. Time to rerun my code. This is the one thing I got to say is by far, I think the worst part of doing any C++ is the tiniest little change, just a fucking rename, and I gotta restart the damn thing. I can't wait to eat my victory sandwich that I left in the fridge for myself. Oh, look at that, it broke. Okay, good. So we're basically starting this off by populating the prototype array based on span x and span y. Okay? While we do this, we could give them the first rules. We could start this off while we're adding the initial rules in here. Okay? And that would be a part of the constraints. Yeah, but then we'd be reading every single time the constraints. So I think we should actually do the constraints after we've generated the initial room possibilities. Can I draw text? Oh, that's part of the widget thing, though. It'd be really nice from a debugging standpoint to... Can I not draw like debug text? Draw debug coordinate system. Draw debug float history location. What the fuck? Does that even mean draw debug string? Oh shit! Yeah! Yeah, baby! Okay, so now what we'll do is every single time we draw this, text location... Oh, fuck. I gotta get the room location. Pretty easy to do. We just do this. I copy this. I give it the dividend. Well, this here, we'll just do this. This will print the length. What I might actually do is also this is the sort of system Crim's going to be explaining at GDC in a few years. Not even I don't think I'll ever go to GDC, to be honest. I don't think I'd ever go, to be honest. I don't know. Oh, for sure, Sky. Renaming folders, especially when other people are touching the project, that's terrifying. I'm going to turn this into a function. This is going to be draw debug text at index. This is also a string. But I love how they call it text, even though it's a string. That's how they get you. How do you like the album so far? It's chill. It's not too in your face, which is good. Except for right now. I feel like this music, I don't know why. Maybe it's my stomach circulating right now. I feel like the music makes me want to shit myself. I don't know about you guys. It's like, it's almost like it's a sign. Like an alarm for my stomach. All right, draw debug string at the blah, 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 blah. Okay, so what I want to do is I want to get, it's giving me anxiety. Yeah, it's kind of giving me a little bit of, this song? Yeah, I don't know about that one. Here's what we're going to do. We are going to cut all of this. And then we're going to bring it over here. Okay. Do I also have to clear the prototype here? I probably should. Okay, where's the string? I don't see the strings. I don't know about you guys. I don't see the debug strings. Draw a debug string at a 3D world location. Don't tell me I can only do it in play. Maybe this is in local space when I give it the test base actor. Working as intended. I just want a debug string so then I can see what's going on. Does this just not have anything? Am I going crazy? UE5 can't see draw debug string. Can't see debug string. Please help. Yeah, it's got, it's opaque. It's red. It's got a duration of 5. Wait, can I not see this debug string? One possible problem, literally took me years to realize this. If you have your game mode HUD class set to none, draw debug string will not work. Also note, draw debug string only works in the game, not in editor. You've got to be fucking kidding me. So I literally can't do draw debug string because it only works in play. That's really annoying. That's it. Time to switch to Godot. Yeah, you know what? Actually, you know what? Yeah, you're right. Okay, let's just do this first. Draw, debug, sphere. So why is that this shit can work, but the other things can't work? See, it is 100% working. It's just for some reason text doesn't fucking work. All right, here's an idea. We draw the amount of spheres based on how many options there are for that area. Dude, why can't I just do text? Draw text. Yeah, but this requires the widget. Draw string. Come on, man. Draw debug string doesn't work in play. You've got to be fucking kidding me. You can do everything else, but you can't do that? Oh, come on. It's a clean solution? I know it is. It's the best solution. Wait, what if I do a segment of 1? What happens? Nothing. Even better, draw the text using the spheres. Time for a sphere to text generator. Draw debug coordinate system. Draw debug box. Draw debug cylinder. Draw debug float history location. What the hell does that even mean? Draw debug float history location? Draw debug frustrum. What even? I don't know what that is. I'm gonna go fucking crazy. Console print somehow? I don't know if you could do a print at location or something. Debug text at location in editor. Oh no, I don't want to have to use a text renderer. I checked the source code and found something. Draw debug string needs to iterate through the player controller list. So I guess it can't get player controller when the game is not running. Why is it iterating through the player controller list? Is the gameplay loop? Mm-mm. Mm-mm. Whatever you're thinking? No. I'm doing something. I don't even give a fuck. I'm going fucking crazy on this shit. Watch this. I'm doing it. I'm doing it. I'm doing the thing I'm saying that I was going to do earlier. If we can't have numbers, then fine. We'll have a bunch of debug. We'll have a bunch of debug spheres. Fine, so be it then. Boom. This is how many options are in each tile. Oh. Okay. All right. Text doesn't even work anymore. Draw. Rename this. Draw options. If there's 0 options, it won't draw anything. This is stupid. Such is life. What can you do? If you can't have text for some stupid reason, then I'll just do things in a dumb way. All right, so we generate the prototype rooms. Then the next thing we need to do is we need to filter all of the rooms doing tile bounds. Okay, so we'll filter the tile bounds. And that will be through prototype index, integer, okay. So what we're going to do here is then we're going to go through the prototype and do a for each loop and do it like this. Well, I guess we technically don't need to do a for each loop because we're just reading off of the index, I guess, but whatever. We could also do that here. Which, to be honest, is probably cleaner anyways. So, filter tile bound. So this will basically filter... Sorry. So, prototype index. This will read where this point is in space. So this means y negative becomes 0, y positive becomes 0 here. So what that means is we need to go through, do a for loop through the tiles. We need to do a for loop through the tiles. So we need to do a get with prototype index. We need to split this. It's going to give us our rooms. Actually, only one of these can be true. So we could just do this. Prototype index plus span. This means there is space. We also just keep this here just because this will tell me what kind of values we need to adjust. Only one of these needs to go through, actually. And then essentially what we need to do is we still do need a for loop through this, actually. And then we need to break this for each loop. And then we basically need to say, hey, if any of these has y positive as 1, then delete it, remove it from... Oh wait, shit. We can't remove it. Do I have to do a reverse for loop, right? To safely remove things? I still don't understand. I guess it makes sense. So if y positive is equal to 1, because y positive here becomes 0. Wait, hold on. Am I doing this correctly? Y positive becomes 0. If y positive equals 1, then we disallow it. So if that's true, we remove it from the list. We'll remove the index. So this removes the options that it can choose from the thing. And then in here, we just do that but for negative. Okay, and then we just got to put this return node here and this return node here. Okay. I think this should now filter it out. And which should be interesting because now we can draw afterwards. And see what happens. It would appear that there's no options in oh, I just realized I'm stupid. I have to get the rooms and then remove that index. Not the actual prototype itself. We leave that there. Whoops. Oopsies. Made a little oopsie. Okay, now we randomize the seed. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I don't think that's doing anything. Is this a... Oh, get. We need a ref... No, that is a reference. Can I not just remove an index in here? Given an array, an index returns a temporary copy of the item in the array. Since there's a copy changes, the item will not be propagated back to the array. Oh, there we go. We have less options. Yes! Look at that. We have less options. Some of them have more options than others, funny enough. So stupid how we're doing this with fucking circles. How many circles we got around here? Okay, so filter tile bounds. Next up, we need to filter the constraints. Next, we need to filter the constraints. Okay, so that's the next big thing we need to do is we need to be certain that the constraints have the correct things that are needed, right? It would appear that the rules have been removed. Huh? Hold on. 0 is x negative, and this one's x positive. I don't select valid room. I think we're gonna change this, or maybe I'll. Okay, we need to move this music. I think that track, I think, is like, I'm gonna go crazy. I'm gonna go insane. So we're gonna copy this and this and this. So we have filter tile bounds. Then we're gonna do filter constraint. Okay. Now to do that, we need to do a for each loop of the constraints after we've already done the baseline bounds checks. Okay. We'll just do it in here. What's the worst that could happen? I'll just turn it into a function later. So we're going to split this. Then we need to get the specific prototype that the tile is attached to, which is right here. Because this is how we're going to adjust a lot of this stuff. It's getting real crazy. This is getting a little messy, should I say. So these are the rules. We can break these here. Actually, oh, I reused it. I didn't reuse it. This is different. Oh, it's different, but not. No, actually, this is the required one. Not a line of C++ in sight. Listen, there's a couple over here. They're just all structs, which isn't really all that crazy. Then we need to go through this for each loop. Hopefully it's a reference. It's not a reference. That's fine. We need to go through here, and then we need to check these. Again, we have to do a reverse for each loop, otherwise it's going to break things. We're going to check this, then we're going to break this. We only need the rules. We're checking against this, 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 or this. Okay, where required is empty. Okay, if this is not valid, so basically false. So if this is false, that means we remove it. So what we'll do is we'll get, I think this is a reference. Yeah, direct reference. So we need to remove index, this index. That's it. Okay, we're getting into spaghetti territory. This is where things get a little dirty, get a little messy. We're getting a little messy with it. So this is going to create the specific rules for the constraints. Now what we'll do is we'll draw the options again. just so we can see what this looks like. So I think the beginning and the end have less options than all of the other ones. Okay, cool. So now we can see that this has 1, 2, 3, 4, 5, 6 options to work off of, rather than the normal 19. I think there's 19 different tiles currently. Wait, is that actually true? I think so. So that's cool. Very cool. I still haven't figured out, by the way, how we're going to delete all of the little level instances that we have. But whatever, that's okay. That's fine. So this will just draw. This will filter the constraints. So let's just do filter constraints. And then this will initial, add, and filter tile bounds. Yeah, this whole like saving the level instances does not work. And it might be because this runs on construction script. Let's just get this off of the construction script. Get this out of the construction script. Move this back here. And uncompleted, run this stuff. Okay, we're making some progress. I think this feels a lot cleaner. It feels a lot more like put together, having all of the tiles have their actual things, and then we can determine like which ones are valid. That just feels, it feels more right. It feels a bit better, I would say. Okay, now we got to go back to our little path stuff. Let's make sure all of this is still working as intended. So once we've completed this, let's go back to our original code, which is basically just generating the points. So now that we've run the generator, we now need to filter based off of our path. Okay. That's the next step. We have to filter based on the path. Because it's not doing that at the moment, right? So it's gonna be a tough one. Oh, God, that's a lot of code. That's a lot of code. That's a lot of code. Okay. So here we're looping through every span. Past path point. Okay, so this just generates the path. Then it doesn't add unique required path. So technically the Literally spaghetti code. It's a little. No, I actually call this nervous system creation. You guys ever see like a video or a clip of like an animal or a whatever like nervous system being formed? Yeah, this is what this shit is. It's fucking spreading out of like one region. This is what your brain looks like on 5GUM. The blueprint is growing, I see. Oh yeah. Oh yeah, it's growing. Oh yeah. It's growing. We've begun switching the system to more of like we keep track of what potential rooms can be in each tile, or the whatever like thing can be in each tile, and then we filter it based off of a bunch of factors. The first one is we filter based off of the bounds of where it is. We have to do, so this is just on the y-axis. We have to do the we do have to do the x-axis. We do have to do the x-axis. And then the x-axis has to also consider the constraints. We have to consider the constraints as well. So now we need to start filtering the paths based off of where we're generating the path. Here we technically kind of do some stuff here. So this is iteration going up or down. Technically, we want x to just be blank. And then y to be blank here. So I think we want to do a few things here. I think we want to separate when we start creating the tile instances. This is still filtering stage. So this should be filtering. This should be considered filtering stage still. While we're at it, I think the spaghetti is probably the worst pasta form. What the fuck is the... What? Worst pasta form? Nah. That's crazy that you would say that. Mods, take this guy around back. Give him like a nice, good bowl of ramen or something. Give him a nice bowl of spaghetti and meatball. Worst pasta form, a tagliatelle? Tagliatelle? Tagliatelle. Yeah, that one's pretty shit. I could agree with that. I don't like the long, flat spaghetti. That one's pretty shit. But there's another pasta that I'm not a fan of. I'm hearing from production that fettuccine apparently is... Yeah, fettuccine's pretty shit. Yeah, I'd agree with production on this one. But how... Okay, hold on. Hear me out. Yeah, that one's pretty shit. Yeah, that one's the bad one. My favorite pasta is the jumbo shells. Those are so fucking good. The shells, the big shells. They get the sauce in it. They get the stuff. That's the best ones. And then right next to that, personally, angel hair pasta. I love thin pasta. They'll be dealt with. Ah, yes. Actually, the spiral one is kind of ass. That one's okay. It's mid, but it's okay. It's not as bad as the fettuccine. Those are bad. All right, so I guess we keep this. Would you guys consider ramen noodles as spaghetti? I know it's not made of wheat. It's made with, I think, rice. Is ramen noodles made with rice? Is it wheat as well? Oh, it is wheat. Rice is not pasta. Okay, listen, motherfucker. I understand that. Stop, get some help. Hey, listen, motherfucker. Listen here, all right? I'm just asking, okay? Ramen is pasta then. It is pasta. Ramen is pasta. Ramen is not traditionally considered pasta. Whatever. AI generated ass. Listen, let's just say it's pasta, okay? Yeah, the one that is rice is vermicelli. Yeah, Twitch, go ahead and ban this channel. Banned? Banned this channel. Oh yeah, I'll ban this channel. Starts playing the guitar. Twitch, play a band on this channel. Randomly a what's the word? Mariachi band comes in. Starts playing on the stream. Not AI, it's from a chef. The chef has been taken over by AI. Anybody can say that they're a chef. Like, listen, I'm a chef. You should see my crepes. If I remember correctly, this is either going up or down. So I believe it's just this. I also think this technically would be 0. Actually, these could be empty. I'll let the boss decide which one of these would be the thing. The answer is no, therefore you are not a chef. Huh? Huh? You're what? I just came back. I'm a chef of Blueprint Spaghetti. Yep. Yep. You heard it here. Is someone who vibe codes a dev? And I answered my own question. I hate that vibe coding has become an actual term now. Like, when I first heard the term, I was like, huh, that's a funny joke. I'm sure it'll pass off. And now it's like an actual term that's being used like across even like mainstream media. It's awful. It's actually the worst thing ever. It's the worst thing that could have ever been done and made, right next to country music. Except for that one song that goes country road to the place. Production's going crazy. I don't know why they're singing in my earphone. Can you stop that, please? Thank you. What about vibe slopping? I'm doing that right now. I'm fucking vibing to music and creating whatever the hell this is. Okay, so we've got the rules while the path is being created. We now need to shit. I guess the next piece of the puzzle. Put this here. Take this, put this over here. Put that over there. I don't want to see you. Put this over here, go here, do that, put the thing there. Okay, so then that way I can start editing this, and then when it's completed, then I'll see the actual completed values. Okay, all right. Okay, so then current path point is an index value. So what we could do here is then take the filter constraint. Why is it empty? Oh, because I put it over here and I didn't change the code. Have I played any of my guitars lately? I have not been playing them as much as I should be. I have not. I've been so zoned out for 3 hours. What the fuck am I looking at? Code. 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 Okay, so what we've been doing for the past hour or 2 hours, essentially, we now generate, essentially what's going on is we generate every point and we give it every single option, like every room possible, or every room in general that can be generated, right? Every single point here. So we have point 1, or we have index 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then what we're doing is then we're going down the list. We're checking a bunch of stuff. A, is it near a wall? Okay, remove any sort of instance that has a doorway that goes in that direction. Then the other spot here. If it has a doorway, delete it on this side. Right? Now what we're doing is when we generate this path, which starts from here actually. This is 0 technically. We now need to give it the pathway that is valid. So it needs to go this way. We need a doorway that goes this way. We need a doorway that goes this way, this way, this way, this way, this way. So that's what we're doing now. Which one is 0? This is 0. I was looking at it the wrong way. The one up here is 0. So now we need to restrict all of the pathways to specifically choose a room that works in the pathway, if that makes sense. So that's the next step. Does that make sense? Yes. Say yes. So what we need to do is copy this code here. You're a genius. Yeah. Yeah. Yeah, I know. So then we get current path point. Wait, no, is this current path point or past path point? This is past path point. I don't know, we'll find out if I fucked up or not. So then we check the required path point, which is current required tile. Okay. And then that removes all the indices. So now if we randomize the seed, look, it has even less options to choose from in the spots where the path is created. Holy shit. It's actually doing the thing. It's working. I love how we made these spheres. They're not even numbers, but you can at least tell what's going on based off of the height of the thing. Do I speak German since I'm in Schottenland? I moved out of Switzerland actually when I was supposed to start learning Swiss German or German in school. Thank goodness. Thank goodness, because that would have been hard. Sprechen Sie Deutsch? No. At 9. Choco's so good he had to move. Listen, it was for the safety of my diet. Okay, so now we need to check if this actually works. Which we won't know until we start generating the tiles. Okay. All right, so okay. So this is where we start generating the tiles. Guys, this is getting a little out of hand. I'm gonna be real. It's the code is it says it's not that bad. It could be way worse, but it's getting pretty bad. This is getting pretty bad. It's getting pretty fucking bad. Brother, what is that? Listen. It's fine. So in here, select valid data. Instead of doing this for the room data set to do the current room pool, we're going to take the prototype and then we want to get the current path point. Sorry, get past path point. Actually, no, get current path point. And then shuffle it. And then it's going to do the same thing as before. Wait, what the fuck are you doing? Wait, what is this doing? No, just select the damn thing. There, just get the first option. Okay, so it's going to select the valid room. Okay. Then add it to level instances. Okay, let's see if this works. Where am I? So this is not going to filter the next rooms. So that would be the next step, is every time we add a room, we filter the other things. What? Oh. Oopsies. We have to do a for loop. Whoops. We actually don't even need this. Go away. We're going to do a for each loop of each prototype. Then we need to break this, and then we're going to get a random array item. And then this is going to select the thing, and then loop body. And then the last thing we need to do is set the array index. Compile. I need a button to delete the things because I can't tell what I'm looking at right now. Okay, so I think it's going in the right direction. We're having a door in the right direction for each one. Now we just need to filter out the doors based off of... Wait a second. So I think we should 100%... Uh-oh. Is this actually supposed to be current path point? Oh, damn it. No, it is past path point. Okay, I think we're still missing a couple parts to this. Thoughts on UE moving away from blueprints? I don't know, man. We'll see when we get there. We'll see when we get there. I accidentally removed a core redirect and corrupted my whole project. Please tell me you're on source control. Please tell me you're on source control, freak. Please. Okay, I see what we have. Okay, I see what we did wrong. The pathway is always correctly choosing a path that I don't think we want to set those. You know, I've actually come to the conclusion that maybe we don't do that. In fact, what we should be doing is setting the current required tile to the current point that we're at. Yeah. Let's just do this, actually. We're just going to reset this. I'm not, but I just started today. I'm just going to create a new project, I think, and never do that again. Oof. Even though I like Blueprint fine, I notice a lot of people use it poorly and end up with hard to track bugs because it's easy to not consider parameter slash variable scope. I think that's just a case of when someone starts doing something new. You know what I mean? I think they probably run into very similar problems in C++. Not similar as in the sense of like those specific things, but they'll probably run into like other problems that would probably cause them to crash even more. Dude, okay. We do need to fix this where the level instances do not retain a reference. And I don't actually know why. Am I clearing it? No, I'm not clearing it. I'm just trying to unload them. Watching this honestly just makes me miss UE4 so much. Why? I would be doing the exact same thing in UE4, you know what I mean? Does that have a door? Okay, so that has a door. So I think we need to do what we need to do with like typical UFC now, which is where, not UFC, what the hell am I saying? WFC. We need to also set the doorway of the past door. Or the surrounding neighboring tiles need to be modified. So that would be the next step, is add the door that is connecting to the path. The problem with that is how do I do that? I wish I could do a loop body, but with a delay. So then I can see how this is generating. But I think if, based on how I did this, it's doing the past tile, which I guess is correct. What we should do for the current path point is hold on. What is this doing again? So the problem right now, the past one is correct. Or correct in the sense that it gets the correct exit. Music reminds me of the high impact cutscenes of Cyberpunk. I think we've exceeded the Machine Party soundtrack, so now it's just auto playing. Auto playing whatever it can play, which I'm all down for. Spotify does a good job sometimes. So so the element that I'm missing right now is first off, by the way, the bounds of the last tile is incorrect. I've noticed some of these, like that one at the end of there is spawning the wrong thing. It's not supposed to be able to do that. Brother, what in the world is that? I also think we don't need the barrels anymore. I don't think the barrels are helping. I don't think the barrels are helping anymore. We can delete the barrels. Goodbye, barrels. It was nice knowing you, but I don't think we need you anymore. I'll just increase the duration of the arrows. So let me get this straight. Every single time I compile this, or recompile it, it, I think, deletes all the references. So, from my understanding, it's always getting the correct next point, but does not always get the correct path, past point. So, how do we filter for that? I think what we need to do, so right here we filter the past path point. I think we also need to do something for the current path point. How do we check for that? So current path point 100% needs something that connects to the doorway. We need to define that. How do we check for that? So hold on, let me just look at this real quick. So this is X positive and this is X negative. This is Y positive, that's Y negative. So from my understanding, the connection points is always going to be the positive to negative. Is that what I'm seeing here? X positive, X negative. Yes. So we're going to get the rooms, do another reverse for each loop. But this one's going to be for the current path point, which is the selected location it's at. We are technically going to have to do this globally, but this is at least for the path. I at least want the path to be correct first, and then we can figure out the other pieces. So how do we know if how do we know if it's the X connecting or the Y connecting? Okay, we'll know. Fart music. We'll know if if I was off stream, I'd listen to it. But hi, Krim. Sorry, I just got here. But did you already consider adding the levels generated to an array and then referencing that array for the room logic? Just got here. But did you already consider adding the levels generated to an array and then referencing that array for the room logic? Did you already consider adding the levels generated to an array and then referencing that array for the room logic? How we're doing it right now is we basically make it so every tile has all of the rooms possible, and then we're basically filtering through the list. And then we start generating the actual rooms after the fact. That being said, this needs another piece to it, which is once we've generated the rooms, the neighboring tiles need to know what this did. That makes sense. That'll be quite important. But we'll do that later. Right now, right now what we need to do is at least do this part here. I guess we could do it this way. Because we still have the current required tile, which is technically the doorway. So, all right, get this. Okay, so we put the array index, we do the same stuff, but in the tile data, we're going to do something a little different. In the tile data, X negative is going to go into X positive is going to go into X negative, Y positive is going to go in Y negative, and then Y positive, Y negative. Okay. We got it. It creates a software answer the rooms it's generating, then you can run logic against it so you don't have rooms generate if it doesn't fit the logic. I'm kind of doing something similar. It basically, we're reading off of data assets that then have a level associated with it. Oh, but see, so big problem here. If here it can't create, it shouldn't be allowed to create a T-junction. So that's where the neighboring system should filter out the things. I'm also noticing something really, really important. Sometimes it's not able to select a piece for the final one. It has no options available, which is kind of silly because oh, right. This we want to delete. There we go. I think that should fix it. It didn't. What in the game dev is that? Listen, man, it's a procedural generation system. What do you want from me? It's not going to look simple. Are the constraints correct? 4, X positive 1, and then empty. I think it's removing options that we don't want to remove. Shit. Removed options don't get reset each tile. No, they do. Just right here, it has a tendency of reading null. Especially when it's going up, which is a specific check that we do right here. Um, did I flip this? I don't think so. Yeah. Actually, wait, no, that's just because there's duplicates. God, that's so annoying. It might be correct. We just have to check. Door, door, end door. Uh-oh. Is this generating the last point? It might be generating just the last point. Here we go. This shit's not deleting properly. We gotta fix that. So that piece generates fine. The last piece seems to run into a bit of trouble. And we know it has no more options, so it has something to do with the option filtering. And it definitely should be able to filter this one out. Like it should definitely be able to find something that can fit that piece. I think it has something to do with this filter. Because once we remove that part, I gotta delete all these again. Then it's fine. I think it's something to do with this, with the way that we're filtering this. I think the problem is it's filtering all of them. Including the Y. So what we might want to do... Oh, this is dumb. We only want to check. We might want to set the. We might want to set the other values to false, the ones that we don't care about. But I don't really know. How do we decide which one should we filter out for the required tile? Also, I wonder if we set this to empty, that's okay. I wonder what happens to our generator. Gotta delete this again. I really need a button to just, every time that thing is compiled, maybe have some way of figuring that out. Man. Okay, that's fine. Yeah, it's kind of annoying. It's not able to find a single option here. I have a feeling it's because it's trying to compare both the X and the Y. And because it's doing that, it's not... Why? Let's try this. This and this. And this and this. Or... Don't think that's correct, but... Yep, it is not correct. Is it deleting? Oh, great, it's undoing the ones that I just deleted. You know what? I have an idea. For now. Can I give the level, can I give a level instance a tag? I know we can give it a level, like a name override, but can we give it a tag? I don't think you can tag a level instance. Let's do this. Hold on. In the construction script, we'll just unload. I don't think that'll work though. And then compile this. No, that doesn't work. I think the problem is that this array gets cleared every time we compile. Which is really annoying. They don't know how to stop it from like deleting the array. And I don't think we can assign a tag to that stuff. Okay, so I think the big problem right now, I think, is when we try to filter the current room, we filter all elements, not just the doorway. So I think what we're gonna have to do is do this. We want to check if the we want to check if the current path point is, this will check if we're moving to the right or if we're going up or down. If this is equal to this, that means we move to the right. If that's true, we're just going to modify the x. Let me actually, this is really dumb, but this is just the only way I can think of doing this really. The whole point of this is to just do this quick. It's not meant to be the prettiest code in the world. That's okay. I'm all right with that. Good piece of Julia. Rest well. So I think in here, let's copy paste this. We're going to make a version 4. So this is equal to this. That means we're going to the right. So that means we can delete checking for the y. Okay. Then this one we're checking for the y here. And I think this should fix the problem. Damn. It's still generating properly. It's just for some reason the end point has no options anymore. Seems like start and end are scuffed. The start is fine. It has a point if it's for some reason anytime we're on the bottom here, it doesn't play friendly, which is part of this. Huh. Well, darn. It has something to do with the right here. I don't know if we need to do something like that. I think so. Goofy ass music fitting the stream and the blueprint code. If the current path point is more than the tile index, iteration going up. If current path point if tile index constraint current path point is more than, yeah, so it means it's below it. That means it's going up. I gotta refresh my memory. When we modify the current required tile, I think we can remove these, by the way. By the way, fix my project. I just had to remove the blueprint class and then recreate it. Hey, thank you, Button. Finally, someone who believes in me. Our big problem right now is the end point is generating with no options. And it generally happens right here. Funny enough, right here. I think it's this. Are the numbers wrong? Y negative, true, 1. Huh? Huh? I don't believe in you. You can't do it. I tried so hard to get to this point, though. Come on. Yep, everything's fine there. Backtracking doesn't... We're not doing any backtracking right now. I think maybe the problem... I thought the problem stemmed from here. It doesn't. So we want to check the Y positive. Maybe I'm doing this wrong. Maybe this is checking X positive and... No, that wouldn't make any sense. X positive on X negative on X positive. Oh, but we have to take into account the constraints. Wait, no. Man, what the hell is going on? Do breakpoint? I don't think breakpoint is going to help me here. Okay, let's just do this. I think I know it's just this one. You guys notice that? The endpoint never generates a door here. Do you guys notice that? And it keeps generating doors on the other side. Here, look. It keeps generating 0, 1, 2, 3, 4. Prototype index plus span x less than. Oh, this has something to do with the y. Prototype index minus span x if it's more than 0. Y negative. Something weird is going on. Prototype index plus span x. Prototype index here is 4. 4 plus span x is 5, 9. If 9 is less than... Oh, shit. Well, no wonder it couldn't work. It could never spawn the door to begin with. Oh, so it wasn't here. It was actually somewhere else. We figured it out in the end. All it took was brute forcing the button 5 million gajillion times. However, we're not done yet. We still have many pieces to go. There are still many pieces to do. Wowee. I can't wait to eat my sandwich after this. Wow, look at that. We did it. Yeah. So that's just filtering for the Y. You might notice there's a door going somewhere it shouldn't. Don't worry, we'll fix that too. The next thing is, of course, while we generate the tiles, it then needs to tell its corresponding neighbors, hey, do this or don't do this. Is this level not... Wait, does this level not exist? Huh? What? It would appear this only runs in editor. Let's try this real quick. Simulate. And it's going to well, it's kind of simulating using the seed I gave it, but that's just for the path. Hmm. Okay, now we just need to detect dead ends. Okay, all right, okay, all right. Okay, all right. Okay. So now we just need to read from the bounds of the X positions. And then cut off the door where it should not be. Great. All right. Great. Next stage is fixing everything else, which is all of the other tiles. And then making sure that it doesn't spawn a point. Actually, this one's fine. It just shouldn't spawn this door. And then, of course, it shouldn't spawn something somewhere if there's a wall next to it. So that would be the next step. Yeah! Okay. I'm getting the fuck out of here. It's been a 5-hour stream, and it's also a weekend. So, I'll see you guys on Monday. Monday. I'm gonna go eat something, and I'll see you guys on Monday, I think. Wouldn't it be fun to release a set of proprietary peripherals that work exclusively with this game? What do you think this is? That one fucking Commander game from, I forget which console, but it's one of the boomer ones. I want to say it was for the NES. I could be wrong. Or Atari. Okay, anyways, goodbye. See you Monday. Goodbye. I might have more of this done. It's been fun. Okay, bye.